Hi all, through this video we will be solving question number 27 from GATE Chemistry 2019 question paper. Among the following compounds, a normal spinel is option A MgFe2O4, B ZnFe2O4, C CuFe2O4 and D CuFe2O4. What is a spinel? Spinels are a class of minerals which has general formula Ab2X4, where A is a divalent cation, B is a trivalent cation, and X is the anionic part which can be oxygen, sulfur, fluorine, selenium, etc. We know that when a crystal is formed, anion makes the lattice and cation occupy the voids, since cation is of smaller size. So, based on which cation occupied which types of voids, we can have different types of spinels. In a normal spinel, the divalent cation A2+ occupies the tetrahedral voids and B3+ occupy the octahedral voids. Whereas in an inverse spinel, A2+ occupies the octahedral voids, whereas B3+ occupies half of octahedral voids and half of tetrahedral voids. We can find a structure is normal or inverse spinel from CFSE or crystal field stabilization energy. If B3 plus CFSE of octahedral is greater than A2 plus CFSE of octahedral, then this means that B3 plus will occupy the octahedral voids and it will be a normal spinel. Whereas if the CFSE of A2 plus in octahedral is greater than that of B3 plus in octahedral, then it will be an inverse spinel. Now, we know how to find whether a spinel is normal or inverse based on CFSE. But if suppose that both A2 plus and B3 plus have same CFSE, in such cases, we will tell that the spinel is a mixed spinel. There are 4 generalized points obtained after solving various spinel structure. If A2 plus and B3 plus are non-transition metal, then it will be a normal spinel. If A2 plus is a non-transition metal and B3 plus a transition metal having this electronic configuration, means except D0, D5, D10 configuration, in that case spinel will be a normal spinel. And if A2 plus is a transition metal with D1, D2, D3, D4, D6, D7, D8, D9 configuration and B3 plus is a transition metal with D0, D5 or D10 configuration, it will be an inverse spinel. And the last point is that if a cation has D3 or D8 configuration, it will always prefer octahedral voids since it will have the highest CFSE. How to calculate CFSE? For non-transition metal, we take CFSE as 0. For transition metal, we can calculate CFSE based on a simple equation. CFSE octahedral equal to minus 0.4 delta O into number of electrons present in T2G plus 0.6 delta O into number of electrons present in EG orbital. And the modulus of CFSE is taken in order to find the spinel structure. Moving on to solving the question starting from option A, MgFe2O4. Magnesium is a non-transition metal and hence CFSE is 0. For Fe3+, the electronic configuration is D5. The arrangement of electrons are shown in the figure. So the CFSE will be minus 0.4 delta O into 3 since 3 electrons are present in T2G orbital plus 0.6 delta O into 2 since 2 electrons are present in EG orbitals. This will give a total CFSE of 0. So in this particular case, CFSE of A2 plus and B3 plus are equal. Hence, we have a mixed spinel. Next option given is ZnFe2O4. Zn2 plus electronic configuration is T10 and CFSE is 0. And the tricationic part, that is Fe3 plus as we calculated earlier, CFSE in this case also will be 0. So we expect it to be a mixed spinel. But due to the size difference between zinc and iron, size of zinc is very much less than iron, and in such cases, the smaller cation, in this case Zn2 plus, will occupy the tetrahedral position and Fe3 plus will occupy the octahedral voids, and we will get a normal spinel. Moving on to option C, COFe2O4. CO2 plus is D7. CFSE in this case will be minus 0.4 into 5 plus 0.6 into 2. Modulus of that will give 0.8 delta O. And Fe3 plus have an CFSE of 0. So we have CFSE of A2 plus, in this case CO2 plus in octahedral, is greater than CFSE of Fe3 plus in octahedral, meaning that CO2 plus will be present in the octahedral voids, and this will be an inverse spinel. And the last option given is CuFe2O4. CO2 plus is D9 configuration, and the CFSE is 0.6 delta O, and for Fe3 plus CFSE is 0. So in this case also, CFSE of A2 plus or CO2 plus in octahedral is greater than CFSE of Fe3 plus B3 plus ion in octahedral, and hence CuFe2O4 will also be an inverse spinel. Therefore, the answer to the question which among the following compounds is a normal spinel will be option B, ZnFe2O4. For further reference, you can visit NPTEL site and the YouTube link is given below.